Brooklyn, can you start us off here?
I would love to.
It says the mean number of wins for a team in Major League Baseball was 81 wins in 2012 with a standard deviation of 11.9 wins. Find and interpret the z-scores for the following teams rounded to three sig figs.
Okay. So this is this the normal IBSL?
Well, a z-score is how you convert a normal distribution into a standard normal distribution, but if we just want the z-score itself, we don't need to use any kind of normal distribution to do this.
Okay.
You just need the z-score formula.
Isn't the z-score formula okay. So then it would be 95. Yeah, 95 minus and then this is 81. With the mean, oh yeah. Oh, I will complicate things way too much. So then 1.20.
Now interpret what that means in the context
Okay.
of the problem.
That they have 1.18% more wins than the average. So
Not percent,
number, like not 1.18.
not number of wins. So what a z-score is telling you is the number of standard deviations
Oh,
that score or that observation is from the mean. So we would say in this case the New York Yankees win total was 1.18 standard deviations above the mean.
okay.
Since it was a positive number, if it was a negative number, we'd say it was
Like below.
below that.
So they're above. So they're 1.1 above it.
And that makes sense, right? If they won 95 and the average was 81,
Yeah, right.
they're winning more than average.
Okay. But it's not percent. Like wouldn't be 1.18%.
Not a percentage.
It's
not a
just the standard deviation over.
Yes.
Okay.
And how much is like one standard deviation? Around 12,
Okay.
right?
Oh.
So they're like, 13, 14 wins above
Right.
average,
Okay.
which is about what it works out to be when you do this subtraction, right?
Mhm. Okay.
Is that okay?
Yeah.
We're gonna skip B because it's the exact same thing. Maggie, we're gonna look at example 2. This says the table below gives the home run totals, mean home run for the entire MLB, and standard deviation for the 4 years when the home run record was set in baseball. Which of the above players had the most outstanding performance relative to his peers for the given year? So if you want to compare things across different conditions, what do you need to use? Excellent, yes. You want to compute a z-score for each of these. So start cranking that out on your calculator and tell me when you get them. Do you need the formula again?
Could be the first one's C equals 60.
I think maybe you have a parenthesis issue with your division, because a z-score of 60 is like kind of an insane number. 60 standard deviations above the mean is like, that's like a hit by lightning percentile.
Oh. 5.44.
That's much more realistic, yes.
And the next one's 3.16. And then 3.87.
Okay.
3.91.
Excellent. So which one of these was the most outstanding performance?
Paper.
The biggest one. Okay, good. Because that's almost 5.5 standard deviations above the average. That is a monster outlier. Right? Is everybody okay with what we did here? And you use this same technique if you wanted to compare like test scores from kids taking the same course with different teachers, or compare like economic data from people who live in different countries to see who's really like the wealthiest relative to their population. Any kind of situation where you're going to compare things across that have different conditions is a pretty good. You okay? Thanks, Matt. Okay. I'm going to skip 3 because it's again just another z-score problem. Lucy, we're going to do 4. So 4 says, for the question below, rewrite the question using the appropriate notation. Provide a sketch of the normal distribution curve and shade the indicated area. Then use normal CDF on your graphing calculator to evaluate the following to 3 significant figures. What proportion of observations in a standard normal distribution are between negative 0.58 and 1.79?
Is this like the 65, 95, 99?
No, you would not be able to use that here. So the first thing you want to do is write the distribution.
Right.
So we're told it's standard normal. So we know X is normal, and then what does standard normal mean? Mean that standard deviation.
Symmetric.
It should tell you the numbers. The mean is the mean is 0, and the standard deviation is 1. Whenever you hear standard normal, that's what that means, right? So we have that. What probability are we looking to find out? The probability that X is
between 0.58 and 1.7.
right? And it asks us to sketch a picture. So there's like our normal curve. So negative 0.58 to positive 1.79, we might estimate as that. So far, so good. The last step then, Lucy, is to take your calculator and compute that probability.
Right.
So what function do we need on our calculator to do that?
The normal
Normal CDF. Where does that normal CDF command live?
second bar.
Second bars. Very good. And then you just follow the menu in, right? And it should be pretty clear what to put where.
I got 0.66.
0.68. The only problem is the directions asked it to 3 sig figs.
0.662.
There you go. Nicole, would you do the next one for us?
Good try.
Okay.
Okay. So the 0 and 1,
Yeah. Well, how did you know that?
because it's a standard distribution.
Great.
And then since it's more than 1.52, yes, you can't do less than.
Let's just write it the way that it states it first, then we can adjust if we need to, okay?
So, field X is, less than, greater than 1.5.
Should be greater than or equal to.
Greater than or equal to.
Does it matter? Why not?
Because I like
Not quite. It doesn't matter,
okay,
but it doesn't matter because we're talking about a continuous distribution.
okay.
If this was a binomial distribution, it darn well matters whether it's greater than or equal to. More than means greater than.
Okay.
Now, if I want to sketch my picture, we're talking about like that, right? How do I compute probabilities for a normal distribution? What command do I use in my calculator?
Let's see.
Normal CDF. Let's look at the inputs on normal CDF and decide whether we need to change this into a less than or equal to inequality, or if it's going to be fine the way it is. It is fine the way it is.
Okay.
So the binomial CDF have to have less than or equal to.
Okay.
If you're doing it inverse norm, that is only going to give you the less than or equal to. But if you're just looking for a probability for a normal, it doesn't matter how the inequality is written, you can just use it. So go ahead and put that in your calculator and see if you get the number to come out. Sure. Are you feeling okay with what we're doing here? Is it helpful to just kind of like, or of course, walk you through this?
They gave me 0.4772.
What did you use for the upper?
Should I use like the one to the?
You should be using positive infinity, yes. So 1e99. And it's good that we're like making these mistakes now. So
I got 0.499. Oh,
this is what I get. The lower is 1.53, right?
I had it like the one before that, and then yeah.
There it
Okay,
goes.
yeah.
All right. Ethan, I'm gonna skip down to D. What proportion of observations in a standard normal distribution are within 1.24 standard deviations of the mean? So start with this, right?
Yeah.
So it's within, the mean is at 0, so 1.24 above and 1.24 below, that's what we want. Does that make sense? So again, like, nothing meaningfully different about how to do this other than like, you know, the verbiage or whatever. What'd you get?
0.755.
Perfect. Yep. Okay. Henry, you want to do E?
Start with X. Go to the line after.
Yep.
And then P. X. Is greater than 2. Any less than 8. Can you flip it?
So it's actually that. Because what we're talking about in our picture, here's 0, so points greater than 0.77
Yeah.
above or less than 0.77 below, right?
5 and 8 equals.
So the way, because it's or, what does that mean in probability land?
It's
Is it add or multiply? Gotta know this, guys.
multiply.
No,
Add.
it's add. So I would do this as two separate probability computations, because you're just calculating this area and then this area and adding them together. Does that make sense?
Yeah.
So do that on your calculator. And what should we be able to say about these two areas? They're equal. Why is that, Lucy? Because it's a symmetric distribution. So if you found one of them, you could just multiply it by 2, and that would be the same thing. Also. Right, so this one is going to positive infinity, that's the upper. That one's going to negative infinity, so it's the lower. Right, for one of them, correct?
Yeah, and then multiply by 2.
Okay.
Be 0.441.
Great. I'm going to skip all of example 5 because it's the same process, except instead of having a standard normal distribution, where the mean and standard deviation are 0 and 1, it's just a normal distribution, and it tells you the mean is in the problem. So just it's the same process, you're just inputting a different mean and standard deviation when you do it. So I'm going to skip those. Is that okay with everybody? I'm just trying to get through a wider variety in our 20 minutes left that we have together. So let's do 6, Massimo. In a recent tournament, Rafael Nadal averaged 115 miles per hour on his serves. Assume that the distribution of his serve speeds is normal with a standard deviation of 6 miles per hour. What percent of Nadal's serves would you expect to exceed 120 miles per hour? So you want to start by identifying the distribution. Hopefully that it says normal in there, you know that it's going to be a normal distribution. And the two parameters we need to identify a normal distribution are the mean and standard deviation, not 0 and 1. So it says he averaged 115, so that's my mean. And my standard deviation is 6. Okay, so now we want a percent. We want P of X. Would you expect to exceed 120? So I want greater than. Exceed. Right? The word exceed means 121 exceeds 120. And now it's calculator time. So you go and do your normal CDF. Yeah, so the 3 sig figs,
Or 20.2, I guess.
2002, right? Or yeah, 20.2. Yeah, that's fine. That's okay. I'm going to skip B because it's again same kind of thing we've done. I just did part A because now it's rather than it telling you the distribution, you had to like identify the distribution from the words. Not much different, but it's a little. Okay, Blake. Let's do 8. It says if the mean of a normal distribution is 85, determine the standard deviation if we know that a z-score of 0.8 has the value of 93.
You have to do like this more like.
Absolutely, we're going to need the z-score formula, so let's write that down.
Then you have like 93 minus 85.
Okay,
And then go like that. Yeah.
And this-
It's equal to 0.8.
yep, and then you're just solving for sigma, right? Is everybody okay with how we filled the parameters in? So as soon as you hear the word z-score in there, probably going to think to use the z-score formula in some way. That's right on.
And you got 10.
Okay. After some algebra, right? Everybody feel comfortable doing that solving? Multiply by both sides by sigma and then divide by 0.8. Should be fairly simple there. Okay. Kevin, I'm going to give you a chance at this one since we skipped you the first go around. It says, given that z is normal 0, 1, provide a sketch of the indicated area on a normal distribution curve, then use your GDC to find the value of A. Round your answer to 3 sig figs. So there's our normal curve, right?
Yeah.
There's 0.
Yeah.
We'll have like 1 and -1, and then 2 and -2.
Yeah.
So we need the area under that curve to be about 0.3. So I don't know, but like maybe somewhere there, that looks like maybe a third or so of the curve.
Yeah.
That feel all right?
Yeah.
Why did I know I was shading to the left?
Just because like the percentile range and everything, so like everything that is, yeah.
Because it says less than or equal to.
Yeah.
Okay. And now how am I going to recover the A value from this?
I don't know.
So there's a command on our calculator. If we want to go from an observation to a percentage or percentile, we use normal CDF. If we want to go from the probability back to the observation, we need to use inverse.
Oh, I see.
So it should be like right next to the normal CDF.
There we go. Negative 0.426.
Great. Now, the one word of caution when using the inverse norm is that your probability statement must be written as a less than or equal to. Okay? Because it's all, the inverse norm is not going to be as flexible as the normal CDF where it can be any old inequality you want. And you can just up or lower, no big deal. Inverse norm is not that flexible. It must be written as a less than or equal to equality. I.e., the probability you're given must be the percentile range. Okay? All right, Lucas, we missed you the first go around. Can you do part B for us?
Where do I find CDF in that?
You want to go second, bars,
Oh, right.
and then that's the distributions menu.
Yeah. Oh, okay. Oh, wait. Is it 0.3 not?
This is 9B. That is incorrect. Okay. I'm guessing what we missed was look at the inequality in our probability.
Yeah.
It is not a less than or equal to. So what do we need to do to make this a less than or equal to?
You have to do the 1 minus the probability of the statement. So 0.61. Oh wait, no, sorry. 1 minus 0.28, which 0.72.
Okay, and that's what you need to do the inverse norm on.
Yeah. And the area is 0.70.
Correct.
Is it, and it's right? Yep. Wait, no.
We wrote it as a less than or equal to.
Yes.
Does it have a left-right option on there?
Yeah, left is
That's
yeah, it's
interesting.
0.5, because if it was the other way, we'd be using the negatives, which to your drawing isn't right, so I'm pretty sure it's 0.5.
Yeah, 0.583.
Yeah.
So if you do have that, I just been so long since I've looked at,
Because if I did the other way, yeah, it would have been negative.
oh, it does have the left, right, center. Well, that's interesting. So we should have been able to just do 0.28. And then we want right.
Yeah, you started that.
And that should have worked also. My mistake. They didn't used to have the that left, right, center option on the inverse norm. So
They make it easy now.
it makes it a lot easier. Yeah, it absolutely does. All right. What do we do for C? Whose turn is it? Probably back to Brooklyn.
So, probably,
So because we're looking for the measurement and given the probability, we need to use which command in our calculator?
is, yep, see, yep.
Neither PDF or CPF. You need to use the inverse norm.
Right.
If you're looking for the observation and you're given a probability, what was our area there? 0.5 something or another, right?
Yeah.
0.54, is that right? Oh, 0.36. The other one was 0.54. And I can just do this as the center. So it spits that out. Which one do I want? Because it gave me two answers.
Yeah. You can be positive one because you can't be less. So they're above, but
So let's think about it. So we have this, right?
Yeah.
So if I plugged in negative, I have the big number as less than, and then the small number is the greater than. That's not the right way. I want the positive.
Right.
Notice here that the negative signs are in opposite locations. What am I going to want? In
Yeah.
this one, the negative that would spit out.
Right. So when you don't flip your signs then?
No, you don't need to do that.
Okay.
You just do it the exact same way. Oops, and it's still center. So here I want the negative value.
Yeah.
Because the negative is going to go here, and then the negative of the positive is going to make that positive there, which is what we want.
Oh, I was looking at C. I was looking at C.
Yeah, we did C.
Yeah.
That we wanted the positive.
Right. Okay.
D we want the negative.
Yes, it is. Right.
because of the inequality
Right.
situation.
So then, do we want?
These are the answers, done, that's it, did it.
Oh.
Those are the values for A. For the respective problems. Does that feel okay?
Yeah.
Morning, Mr. Sharp. Are you Miss Gold?
I just go.
Gonna scroll.
Yeah.
Fun.
All right.
Okay. It'd be nice being there.
Okay,
That's right, that's right.
let's do 11
Okay, I will.
as our last one. I think we're just about out of time here. I would encourage you guys, though, to spend a little bit of time working through these in-class examples. They're not, some of them are not trivial and can be a little tricky. Well, this one seems so innocuous, like in a standard normal distribution, 20% of the observations are above what value? What does this value represent? Well, we're not sure. Let's start by like writing some stuff down, right? Everybody's okay with that? How am I going to compute my value for A? That's what we're looking for, right? What's the area? And do I want left or right? Or center? Think about the picture. Here's A, and above it,
Right.
I want right.
Yeah.
So if you're not sure, draw the picture, right? And what does that come out to? I have 0.842. So what could we say? So this spot over here then is 80%, right? So this is the 80th percentile. So the 80th percentile would be 0.842 standard deviations above the mean, right? We'll stop here because we're kind of at the end of things. Again, for Sunday's problem set, I think I want 12.2 and 12.3, or is it just 12.2? I forget what I-
12.3 is next time.
Okay, so just 12.2 for Sunday. Next class, we'll do the chapter 12 activity. That'll be a 12.3 based activity, so we'll be using normals. And then we'll be taking the chapter 12 test the following class
Thursday.
on Thursday, so I would
No,
recommend.
sorry, it'd be Friday.
Correct, we're Wednesday and Friday. So I would recommend, if you don't feel comfortable with the normal stuff, to work through, make sure you have that, try to do that 12.3 homework sooner rather than later, and work through some of these in-class examples. The key to the in-class examples is up there, okay? Some of the work, it may seem more complicated than necessary because I wrote these keys without the left, right, center, inverse norm option. So are like, why are you doing all this stuff? Can't I just do it this way? The answer is probably you can just
Thank
do it
you.
this way.
Thanks, Jim.
Not all,
Thank you, Dr. Kula.
I would talk to Ms. Sagers. She would be able to probably look it up and tell you instantly. I don't have that written down anywhere right this second, but it's a 2-dayer.
It's a 2-dayer, all
Yeah.
right. Thank you.
You're welcome, Ethan.